Hey everyone, today we're back with a hard level SAT math question. Here we have the table above gives the values of some function f for some values of x. Which of these equations can define f of x? So the first thing that we're going to notice here is that we have a decreasing function, an exponential decay function. We're going from 5 to 5 halves to 5 fourths to 5 eighths, right? What this means is that we need to have a negative exponent, okay? That means that here, right, x has to be multiplied by some sort of negative coefficient. This plus one doesn't really matter for, our basic overview purposes of what we're doing right now, right? So here we have a positive x, here we have a positive x. When we multiply out the negative sign, here we're gonna get is negative x minus one. So this is a negative x, so this works, but these two don't. And then this one here is also a negative x. So it has to be one of these two. Why? Because both of these will show exponential growth. And you could always prove this in the actual exam by just looking at your Desmos calculator and putting these functions right in. That's one of the great things about the digital SAT. Now, what we also know here is that these two, because we have this plus one or this minus one in here, right? We're going to get different values for basically every single value of, f of x, right? So what we can do is we can take any value of x, let's say we take 2, put it into both these functions. So input 2 for x here, input 2 for x here, and we're going to get two different values. And only one of them is going to match up to 5 fourths, which is equal to, of course, 1.25, right? So what I did is I put that in our Desmos calculator, digital PSAT, NMSQT, and SAT version calculator. I put 2 in for x here, I put 2 in for x here. This was the function from option C, this is the function from option D. We see here that the function from option D gives us 1.25, which is of course the correct answer. That means that with finality, we can highlight D as being our correct answer. Now another way you could do this is by using the table function in Desmos. What you would do is just click on this icon here after you put in a function. So let's say that I typed in, just some random function, 5 to the x. I hit this button. There would be an option that shows up that says table, looks just like this. You can manipulate the x values to whatever you want. So you'd probably manipulate them to whatever's in here. And then whatever function matched up with those values, you'd be able to simply match that. That, however, would probably take a good 1 minute, 1 minute 30 seconds, even 2 minutes to do on the actual exam, which of course is a significant amount of time that you might not want to spend. So I would always recommend, if you have a question just like this, first see what options you can eliminate easily using something like that exponential growth or decay trick, and then go from there.